Hello everyone, I hope you're doing great, and today we're gonna build a regulated power supply board using those components. And this board is going to use the AC output of the transformer, which is gonna be rectified by the diodes, and is gonna be filtered from those huge capacitors and create a stable DC voltage. This power supply we'll also have some regulators installed, which they are going to step down the voltage from the peak voltage to 15 volts, and in this way we're gonna have a headroom, and we're gonna use the regulators to create a stable voltage even when we ask the power supply to give us big current, because we're gonna have the headroom or the voltage difference between the regulators and the voltage peak. We're going also to use some various filtering capacitors that they're going to decouple some noise and high frequency noise. And so we're gonna go ahead and in this video I'm gonna show you the schematic on the Ultimate Designer. I'm gonna go over all the components that I'm going to use from this for this build. We're gonna solder all the components and try to figure out the positioning and all that stuff, and then we're gonna try to do some testing on the oscilloscope and see if we have any noise or high frequency oscillations and stuff. So before we get into the video, I want to let you guys know that if you like this kind of videos, please give me a sub and like the video, because it helps me a lot and it helps the channel grow and motivates me to do more videos like this. So let's go over the schematic and see what's going on there. So here we have the schematic of the power supply that we're going to build, and as you see, it's pretty simple. We've got the AC inputs on the left, and this AC voltage passes through those two diodes that are going to form a voltage doubler, and in this way we're going to use the positive peak of the sine wave for the supply of one rail, because we're gonna have dual rails, and we're gonna use the second diode to rectify or to use the negative side of the sine wave, and we're gonna supply this way the negative supply, or the negative supply, the supply relative to the ground. So we're gonna also use these huge snap-in capacitors. They are 10,000 microfarads, and these capacitors store a lot of energy for cases like when we don't want to use the unregulated, we don't want to use the regulated output, and we want to use the unregulated output. We're gonna have we're not going to have a stable voltage, because we feed current directly from the VCC, but we're gonna have much better current capabilities. And also this capacitor is gonna do the smoothing of the AC signal. As we move to the right, we've got the two regulators. These regulators have an input and an output, and they use internal transistors to create a stable voltage at the output, and this output is actually 15 volts. And we're also going to use the same transistor, the same regulator, but this regulator is negative regulator because actually the ground is at higher voltage than the output. And this regulator also, like the one above, uses internal transistors to hold the voltage on this point stable and bring this voltage up. So we've got 15 volts across this across ground and this point. We are also going to use two capacitors here. These capacitors are 25 volts, 470 microfarads, and this they are going to provide some storage for energy when current is needed fast through the regulated output. And we're gonna use some smaller 25 10 microfarad capacitors and some 0.1 microfarad capacitors. These are ceramic capacitors that they're gonna do high frequency and radio frequency noise decoupling, and they're gonna bring those noises that are caught up by the 15 volts and the minus 50 volts rail, and they're gonna get shorted to ground, so we don't have any noise at the output. Some notes that I want to make: you need to check the maximum input voltage of your regulators, because if you feed more voltage, AC voltage across the regulators, this is going to might create some damage to the components. And as I said, we're gonna use these power big snap-in capacitors to have current capacity for the unregulated output. And also, as I said, these smaller value capacitors are recommended for radio frequency and high frequency decoupling. So we got over the schematic, and now we're gonna go over the bench and see how we're gonna lay out the board and check how we're gonna solder and the stuff. So I'm gonna go over really fast to the components that I'm gonna use. I'm gonna use this cable and some alligator clips for the output voltage for the output, so we can connect output voltages of the unregulated and the regulated output to our circuits. We're gonna use these two 470 microfarad 25 volts capacitors. We're gonna also use this smaller value 10 microfarads and also the ceramics. We also have the diodes. We're gonna use those two diodes that I have laying around. We here have the regulators. The one is positive and the other is negative regulator. And I also got some heat sinks that I salvaged. I really want this to be as stable as it can be, so we have a pretty stable supply when I want to power my projects. We're gonna use those big bulky capacitors, as I said, for current capabilities of the unregulated power. And I'm also gonna use some terminals. I'm gonna use two terminals for the inputs of the two terminal output of the big transformer, and we're gonna use a 6 terminal which the two middle they're gonna be the ground, the outer two they're gonna be the regulated output, and the final two outside at the terminal they're gonna be the unregulated power. So let's see how we're gonna lay out the board and come back. So after a long time and some fails, as you see, I did some rough layout of the big components here. I've got the two terminals, the input and the output terminals. I've got the two diodes that form the voltage doubler. We've got two big capacitors in series. The same happens to the front capacitors, which move a little bit and wiggle. And I also have the small capacitors at the same polarity, and also the ceramics. I also left some wires here so I connect directly the capacitors together. And for now I'm gonna figure out how I'm going to put my regulators right here at the corner, and see what how I can do this, because the terminals of the regulators are quite rough and I don't know how I'm gonna do it. So let's figure it out. So we're gonna first start with the positive regulator. The ground is on the middle, so I will probably move the front pin a little bit at the front so it's closer to the pins, or I might do it I don't know, maybe like, and then I will try to solder the things without doing any bridging. As I said, we have the positive regulator on the positive side of the capacitor. So let's warm up the first regulator. As you see here, it's connected to the boards, and we're gonna try to figure out the second one. Now has a different pinout. I need to figure it out again. And actually the first is ground, the second is input, and the third is output. The third is output, so these need to be flipped like that, and it's pretty fine. As I see here, I'm not gonna squeeze it a lot. There we go, the board. There we see the board, and now we have to do the connections. I want to first start with the capacitors, the front, the back, and then try to see how I'm gonna move these two. So let's figure out first the fronts and the back. Pretty difficult. This is more difficult than soldering PCBs. And lastly, the reg. The reg is ground, so we need one last ground cable here. And as you see, the board is finished. I have done the grounds, and I put in some wires because I couldn't cross copper, and because I'm going to have a short if I cross. And we're gonna check with the multimeter if everything is fine and everything is connected, and we're gonna give it a test. We put beep mode to check if we have any shorts on the input, on the output, And as you can see on the input, we don't have any shorts. We've got two grounds here. Yep. This is not, this is the regulator. This is not sorted too. The middle of the regulator should be ground. There we go. And output should be the third. So let's check here, third. There we go, we've got continuity. No continuity across ground and input, so we're fine with this. This is input. There we go. And the outputs, no shorts. Middle. And no shorts at the outputs, neither on the inputs. So let's connect the transformer and check if we have good voltages. So let's connect the transformer to the plug and take some distance in case we've got a reversed cap or something, but I don't feel we have anything reversed. Let's take the distance, and nothing blows up. And let's check for voltages. We should have 20 volts, and yes, that's the peak, the DC peak. There we go, that's the unregulated power, and that's ground across minus 40 volts. There we go. And we should have a ground and minus 15. Yes, everything is working. And we should have plus 15 on this side, almost. There we go. And we should have around 30 across the regulators, and everything is working pretty nicely, as we see. So we're gonna put some loads, and we're gonna connect the circuit to the oscilloscope and see if we have any high frequency noise that the oscilloscope can take. Also, I should mention that it would be smart if I added a discharge resistor or something for the regulators, but as I see here, the voltage of the capacitors drops, and that's maybe because of the voltage difference on the regulators that dissipates all that energy stored on the capacitor. So that's a good indication that voltage is falling, but just be safe and don't touch the terminals after you unplug from the plug. This video took a little bit longer than expected, but I want to do some final tests rails basically, because I've got some filtering caps, and I want to see how much noise and high frequency pickup I've got from the surroundings. So I'm gonna plug the thing. I don't have anything sorted. There we go. It's connected. We're gonna check again for voltages. And I don't want to hide this. So I've got the positive lead here, and from the negative I've got 14.7 volts, and from the ground I've got 4.9. It's a little bit of difference, and we're fine from voltage perspective. Now I'm gonna plug the probe of the oscilloscope at the first input, and I want to zoom in the thing and check for noise. And as I see here, I see a little bit of noise. I'm going to expect to I've got the input on DC coupling, and I've got first channel on. I'm gonna zoom in and see how much noise we have, and the probe is actually on 10 times. No, it's on 1 times, And as we see here, I've got at 0.5 millivolts per division, and we've got less than a line of noise pickup. And if we also increase the time division, and we don't see anything here. That's pretty much limited from the bandwidth of the oscilloscope, and we actually don't see any noise. And I'm actually going to turn on my switching power supply to see how much noise pickup I've got from the systems around me. And I'm gonna turn on I don't have anything sorted here, no. I'm gonna turn it on, and as I see here, I've got some more pickup, but it's again pretty small. It's 50, like that's around 50 millivolts of noise, and it's because of the power supply, the switching power supply. And switching power supplies are very noisy, but still it's pretty the line is pretty clean. So if we turn on the switching power supply, we see all that noise goes away and we don't have that problem. For testing, just do the comparison with the non-regulated rail that has no filtering at all. It only has the filtering, and as we see here, the noise is pretty big, quite bigger, as you see here. And if I turn on the switching power supply, that's even you can see it from the camera. And last thing we're gonna do is we are going to load the regulated supply and see how much the voltage of the regulated supply drops. So as you see here, I'm gonna load the plus 15 volts regulated with 2 watts, almost 2 watts of power, and we're gonna see how much voltage fluctuation we have. Come on. And we've got 14.7, which was actually pretty much the same as when the rail was unloaded. And because I want to use this regulated power for voltage amplifiers and generally circuits that don't require a lot of wattage, and I don't wanna have noise, and I want to have a stable voltage, we actually achieved our goal to have a stable voltage. So that was the video all about. It took a long time. Actually, it took me almost 2 hours to solder the board, but everything worked flawlessly, and I'm so happy about that. So I'm gonna link the schematics and my GitHub page at the bottom of the description, so you can check the schematic if you want to make the same board. And also there is going to be maybe a live that I'm gonna do, maybe a PCB board design on Altium, so that would be a fun idea, and maybe a nice, more professional project just for for the exercise. And there are gonna be more videos at the future at the ET or electronic topics series. So if you want not to miss this kind of videos, you can give me a sub and like these videos, because it helps me a lot. So thanks for those who stayed pretty much from the end, and I will catch you in another video. Thanks for watching.